Welcome to this lesson on finding the area of parallelograms. Please make sure you have these notes in front of you so we can begin our lesson. The learning objective for today says, I can solve parallelogram area problems. Our first vocabulary word is called polygon. And a polygon is a closed figure formed by three or more straight lines. A rectangle is an example of a polygon. And a rectangle is a quadrilateral. The word quadrilateral has the word quad in it, which means four. It has four sides. So it's a quadrilateral with opposite sides parallel. Parallel means the sides never touch. And opposite sides that are equal length. A rectangle also has four 90-degree angles. So here's an example of a rectangle. This side and this side are equal lengths, and they're parallel. And this side are equal lengths, and they're parallel. Inside of this rectangle, we have four 90-degree angles. So the blue lines would be my base, and the red lines would be my height. So if I wanted to find the area of this, I would say the area of a rectangle is equal to the base times the height. Now a square is also a polygon, and it's also a quadrilateral with four equal sides and four 90-degree angles. So a picture of a square would look like this. Four equal sides and four 90-degree angles. If this side is worth S, then all sides are worth S. And the area of a square would be area is equal to side to the second power. So let's go ahead and review these shapes. A square would look like this, and it has four 90-degree angles. Each side is worth the same. A square can also be called a rectangle. And a rectangle has two sides that are parallel and two sides that are equal. And we also have four 90-degree boxes. Notice a square is a rectangle, but a rectangle is not a square. And the last thing would be a polygon. A square is a polygon, and a rectangle is a polygon. And a polygon would be a shape that is enclosed by three or more straight lines. So let's talk about more vocabulary. A parallelogram is a quadrilateral with opposite sides parallel and opposite sides that have the same lengths. So it looks like the same definition as a rectangle, but the only thing is a parallelogram does not have 90-degree angles. So it looks like something like this. Four sides, two sides that are equal, another two sides that are equal, but we do not have 90-degree angles. In this case, our base would be down here, and our height would be a dashed line that stands nice and straight and tall that forms a right angle. So this would be our height. So the area to find a parallelogram would be area is equal to base times height, just like a rectangle. If they ever give you a number on the slanted sides, please make sure you ignore those numbers. You do not use those numbers. Those numbers are not the height or they're not the base. The next vocabulary word is called rhombus, and a rhombus is a parallelogram with four equal sides. So here's an example. Usually it looks like a diamond shape. So for the key concepts, let's go ahead and write the word rhombus. And a rhombus, like I said, looks like a diamond shape. A rhombus is an example of a parallelogram. And a parallelogram has slanted sides that are parallel, and two sides that are equal, and two other sides that are equal. Finally, both a rhombus and a parallelogram are known as polygons. And a polygon is a shape that has three or more straight sides. So let's use these key concepts to discuss the following examples. For example 1, it says find the area of the parallelogram. So let's go ahead and recall the formula for the area of the parallelogram, which is area is equal to base times height. Now let's take a look at the information we have. The base would be the bottom portion of our little parallelogram here. So if we count the units, we have 1, 2, 3, 4, 5, 6. So my base is worth 6 units long. Our height is the line that is the diagonal line that touches the 90-degree angle. So if I count those boxes, I have 1, 2, 3, 4, 5, 6, 7, 8. So our height is equal to 8 units tall. Let's use these numbers and plug it into our formula for area. So area is equal to our base, which is 6, times our height, which is 8. When we do the math, 6 times 8 is 48 units. And since we're talking about area, units squared. And that would be our answer. If you went back and you counted all the little blue squares inside of our parallelogram, we will get 48 of those blue squares. Example 2 says find the area of the parallelogram. So let's recall our formula, which was area equals base times height. Now let's take a look at the problem to see what information we have. Our base will be 20 centimeters because it's the bottom part of our parallelogram. And for our height, we've got two choices. We've got the 13 centimeters, which is our diagonal line, and we have the 11 centimeters, which is the dash line that is standing straight and tall. If you recall from your key concepts, the diagonal line is not the height. They're just trying to use that number to trick you. The height is the line that touches the 90-degree box. So our height in this case would be 11 centimeters. Let's use these numbers and plug it into the formula for area. So area is equal to 20 times 11. So when we do 20 times 11, we get 220 centimeters to the second power. And that would be our area for this parallelogram. So pause the video and complete these got it problems, and we'll discuss the answer in class tomorrow. Notice we have two got it problems on this slide, got it problem A and got it problem B. For example 3, it says find the missing dimension of the parallelogram. So they're not asking us to find the area because if you look at it, they're already giving us the area. They're saying the area is equal to 45 inches to the second power. So let's go ahead and recall our area formula. Area is equal to base times height. Now they've given us our area, so I'm going to plug in 45 for the A. And if you notice, they gave us 9 inches. That's our base, so 9 is our base. And our height, we don't know. We're going to call the dash line H, so we're going to times it by H. What I can do now is I can solve this problem by drawing a fulcrum down the center of the equal sign. And to get our variable by itself, which is H, let's go ahead and, since we're multiplying by 9 times H, we can divide by using the inverse operation. So 9 divided by 9, well, that's going to go away. And 45 divided by 9 is equal to 5. So the value of H is equal to 5 inches long. Now to check your work, you can plug it back into the formula for area. 5 times 9 is equal to 45 inches to the second power, which is our area. So pause the video and complete this got it problem, and we'll discuss the answer in class tomorrow. For example 4, it says Romelia is painting a replica of a national flag of Trinidad and Tobago for a research project. Find the area of the black stripe. So the black stripe is shaped like a parallelogram, so we can use the formula area is equal to base times height. So my base would be 6 3/4, and the height would be 12 inches. So let's go ahead and plug this in. Area is equal to our base, which is 6 3/4, times our height, which is 12. Let's go ahead and make that mixed number look like an improper fraction. So we get 27 over 4 times it by 12 over 1. And then we can go ahead and cross cancel. So 4 goes into 4 once, 4 goes into 12 3 times. And we can multiply straight across, so the area would equal to 27 times 3. And 27 times 3 is equal to 81 inches to the second power. So the area of that black stripe is worth 81 inches squared. So pause the video and complete this got it problem, and we'll discuss the answer in class tomorrow. So now that we've finished watching this lesson, go ahead and self-rate yourself and let us know how you feel. If there's any part of this lesson that you do not understand, please go back and watch it again. Also come to class with some questions so we can discuss it in further detail.